I was telling you that the control NOT gate, when you prepare the second qubit in state 0 and the first one in state x, where x is either 0 or 1, gives you at the output state x, and the second qubit learns about what is the bit value of the first qubit and goes into state x. So it looks like you clone the state in the first qubit. It looks, your first impression may be, I have an interesting operation, x0 goes into xx, I duplicate a state. Can I do it for any state whatsoever? So if I have a state psi, which is not necessarily my basis state by some state of a qubit, and I just place my second qubit in state 0, do I get psi tensor psi? Well, let's take a look. Do we have a cloner or not? So say, let this input be psi, and let this psi be of the form alpha 0 plus beta 1. Let's see what we are going to get at the output. So if we start with the state alpha 0 plus beta 1 on the first qubit, and the second qubit is in state 0, so that is equal to the state alpha 0 0 plus beta 1 0. So apply C0 gate. What's going to happen? You see, the first term is not going to be changed, right? Because we have the control is in state 0, so nothing happens to the target qubit. So we have alpha 0 0 plus, well, this one will be different because now we have state 1 0, the control is on 1, so therefore we have here state beta 1 1. Okay, so that's what it is. Is it the clone of psi? Well, it isn't, right? So if what do we expect? So if we were to clone the state alpha 0 plus beta 1, so then the state psi tensor psi would be of the form alpha 0 plus beta 1 tensor alpha 0 plus beta 1. So that is a state of the form alpha squared 0 0 plus alpha beta 0 1 plus beta alpha state 1 0 plus beta squared state 1 1. So clearly this state here, the clone, and this one here are two different states, except when alpha is equal, one of the coefficients is equal to 0. In this case, we have our psi is equal either to 0 or to 1, in which case, and only in this particular case, we do clone the state, but from the first qubit to the second qubit. But other than that, you can see that whenever we have state psi that is a superposition of 0 and 1, our control NOT is not generating any clone. In fact, it just simply entangles the two qubits. So this, except a special case where one of those two coefficients is 0, so when we give it state 0 0 or 1 1, otherwise this is an entangled state. This is an entangled state of the two qubit in which the second qubit is learning the bit value of the first qubit, but is certainly not cloning it. Which, leaves an interesting question. Is it possible to clone a quantum state? Is this kind of process possible? And I will leave it for you to play with, and you can either use the fact that evolutions in quantum mechanics are linear, or you can use the fact that those are that has to be unitary operation that could possibly involve some other systems, and you can then show, whichever sort of approach you take, you can actually show that quantum cloning is not possible. So if I give you an unknown quantum state, I give you a qubit in a state that you know nothing about, and I tell you, can you then just reproduce this state? So I keep the original and generate a clone, a copy of that state. So if you know nothing about the state, that's not possible. There's no physical process that would allow you to do it. So in general, quantum information cannot be cloned in this particular sense. But of course, you know, if you know that if you know something, like if I tell you, well, it's either in state 0 or state 1, then you can clone. But in general, when you have zero information about the qubit I'm giving you, there's no universal cloner that would generate a clone. And that's a wonderful exercise for you to try. So that means that you'll understand. So it's clearly the case that, you know, I just wanted to show you here that the control node is not a cloning device.